Hey guys, so today let's look at Leetcode 2060, which can also be asked in Facebook interviews. So for this problem, we're gonna compare two encoded strings and to check if they are the same or not. So let's go through an example to see how a string can be encoded. So let's say this is a string and we want to encode it. So we can, first step is like we can randomly split it into a list of strings. So let's say like this string can be split into these. So basically every substring can be any length, and the length must be larger than or equal to 1. So we can just split this string and randomly pick a length and then split into this array of substrings. And then the second step is like you can randomly pick any items in the list and just get the length of the substring. So this can be encoded into these substring. So basically AB, we just choose not to encode it. And then this one, we randomly pick it to be encoded. So the length of the substring is 12. So we replace it with 12. And then this string, we randomly pick it to be encoded, so it can be 1. And then P, we remain unencoded. And then the output will just be joining all the substrings together. So this is will be output of the encoded string. So it will be AB121P. So the question is like, given two strings, right? And we just return true if it's possible that the two strings are the same string. So let's say the first string is internationalization and the second string is I18N. So this one has no numbers in it, but the second string has a few numbers in it. So let's say this can have three cases, three possibilities for the original string. So either I followed by one character and then 8 characters and then N, or it's an I followed by 18 characters, then N. And in this case, it's like I followed by 18 characters and N, and then it matches like I followed by 18 characters and then N. So we return true because it's possible that these two original strings are the same. And another case is like this one, S1 and S2. So this is more complicated because we have numbers in both strings. So for the first S1, it can have multiple possibilities, either like L followed by one character, then two characters, then three characters, and the E. Or it's L followed by one character and then 23 characters and the E. Or it's like L followed by 12 characters and three characters and E. Or it's like L followed by 123 characters and E. And the second string can be either like 4 characters and then 4 characters, or it's 44 characters. In this case, there is one possibility that these two strings are the same string because if it's like one character, L followed by one character, then two characters, then three characters, then E, then it's like 8 characters in total. And here we have 4 and 4 characters, then it's 8 characters in total. So if in this case, then they can be possible that they are originally the same string. So we return true. And in this case, it's A5B and C5B, right? Although the length will always be the same, like the length of the original string will always be 7, but this A doesn't match the C here because the first character, they don't match. So it will never be possible that these two strings are included from the same string. So it will return false. All right, so this seems a very difficult problem because we have we have numbers on both in both strings, right? And also, like when there is a number, there are multiple possibilities. Like in this case here, like when the number is 1, 2, 3, then we have to consider all the possibilities. Like either it's 1, 2, and 3, or it's 12 and 3, or it's 1 and 23, or it's 123. So basically, we just brute force all the possibilities and check if the original string are the same or not. So in this case, we just use brute force to brute force out all the possibilities in the check. And for this, we can further use backtrack and memorization to improve the efficiency. So let's try to start sort an algorithm. So so let's say like if so when we are analyzing a string, right? So as long as like the length is the same, and then whenever there is a letter, whenever there is a character like non-digit character, and they matches with like on both sides, then we can tell like the two strings are originated from the same string. So let's say if we see like L here, right? And we see a number here. So let's say 4, right? So we can say like we are at index 0 for both strings, but and then we reach a 4 value of 4 for this position at the second string. So which means we have a possibility like we have 4 characters already for string 2. So this means the string 2 is already 4 positions ahead of string 1. So they have a difference of 4. So string 2 will already have 4 characters. So this 4 can represent 4 characters. So either already like 4 positions ahead of string 1. And or maybe it's already 44 characters ahead of string 1. So, and then if it's 44 characters ahead of string 1, then the second string will reach the end. And no more, we already reached the end of the string, right? Then we can just move the string 1. So it either like we have one character, right? So it will have a difference of 43. So we minus 1 because we move it by one position. And then it's 2, 1. So we can either treat it as one character, then we're going to have a difference of 43 minus 1, which is 42. Or we can choose to move 12 characters, which then we're going to have a difference of 43 minus 12, which is 31. Or we can choose to have 123 characters, but which will be impossible because we have maximum 43 difference. And if it goes by 123 characters, it will go beyond the range. So it will return false. So we can just try 1 and then move 23, move like let's say 23, so it will be like 42 minus 23 will be 19 difference. So basically we just try to move like in positions from both strings and track the current difference they have of the string length. And if it's a number, and if it's both are letters, and then if the difference is 0, current difference is 0, then the both letters must match. Otherwise, it will return false, right? They don't match. Otherwise, they can be originated from the same encoded string. If they still have difference and the values don't match, then if they still have difference and they are both letters, then we can move the whatever string like is currently shorter to move ahead, to move the positions ahead, so that to even the difference, right? So basically, that's the algorithm. So let's try to code it out. So for backtrack, usually we need to define a helper function. So, and in this case, the helper function, we need three input parameters, which are the indexes of the current positions of the both strings and the current difference we have, as we discussed. Like we need to keep track of the difference of the current positions in the strings, so that like in the end, we need to, for both strings, we need to move to the end position and then maintain the difference of 0. Okay, so let's just try to make the definition here. And then the initial condition is like we just need to return help. Like initially we have both strings starting from position 0. And then initially they have a difference of 0 because both of them have a length of 0 initially. All right, and let's have mn defined. So n equals length of s1, and n equals the length of s2. So when we return true, so we will return true. So now we start implementing the helper function. So first we need to define the true condition. So when it returns true, is like if both reaches the end, I equal to n, and j equal to m, right? So now both strings we iterate to the end of the position. So if is 0 equal to 0, then we return true. Otherwise, we return false, right? So basically, we can just return this here. We return, all right? So if both of them reach the end of the string, like we iterate to the end of the both strings, and then they have no difference, then we can make sure like they can be originated from the same input string. Otherwise, it's not possible. Like they still have a difference. So that's the condition. And also we need to keep a so as I mentioned, like for backtrack, we can optimize the performance by using a memorization. So let's keep a memo. Like we memorize the previously calculated results because in backtrack, we're going to exhaust all the possibilities. So sometimes we may revisit the same condition again. So then if we memorize the result, then we don't need to recalculate the same process again. So let's say memorize is a DICT. So if this condition is already calculated before, if in memo, then we just return it directly. Oh, sorry. Now let's consider all the other possibilities. So let's say if the current position in string one is a number, right? So what are we gonna do? So we first need to check if I is less than n and s1 I is a number, is integer, is digit. All right, so now let's check if it's a digit, right? So we need to, so if it's a digit, and there are multiple possibilities, either use a current digit and use its length to move the string, or we use a current digit, and if the next one is a digit as well, then we just like use, like for example, if it's 1, 2, 3 here, we can either do 1 or 1, 2 or 1, 2, 3, right? So we have three possibilities. So as long as like the following numbers are digits. So let's say let's track the value of the number. So let's say number is 0, and then while I is less than n, and as long as it's a digit. Oh, actually, let's set k. So because we are looping through on the first string, so we just set it, assign it to k. Is backtrack while k and this sik is digit. So the value of the number can be number equals number times 10 plus an integer of the value. Okay. And then we can increment k by 1. And if, so we need to check if it exists, if it's valid, so it will be k. It will be k. And then the difference, because we are moving the first string by a certain distance, right? So the difference will become smaller if they have. So we're just gonna minus the number. So we're gonna have a smaller difference between those two strings, or maybe if it's already negative, then it will be a larger difference, right? So, but if it's a valid solution, we return true. Otherwise, we return false. So basically, the final condition will return false. So we are just trying to find all the true possibilities for this condition, for this status, for this state. All right. So yeah, and also you can keep it in memorization. Memorize the result. So all other cases will be false. So let's check another true case. So otherwise, if j is less than n, okay, so the second string is a digit, and 2 is a digit. So what are we gonna do? So we're gonna do the same. Let's just copy paste it here. So the number is 0, and now this case it will be j, and the k is less than n, and the s2 k is a digit. So we're gonna update the number, and then k plus 1. So this will be I and the k, I and the k, and now this difference we just gonna increment because it will, like we So whenever the second string moves ahead, we're gonna increment the difference, and whenever the first string move ahead, we're gonna decrement it. We're gonna decrease the difference. So this is the only condition when the second string is a digit. Then this is the only condition when it returns true, right? Okay, now if both are not digit, both are characters, then what are we gonna do? So if both are characters, then there will be three conditions. If the difference is zero, then both char must be the same. Otherwise, we're gonna return false. If the difference is larger than zero, then we have to move the first string. We have to move ahead of the first string, right? And if the difference is smaller than zero, then we have to move ahead on the second string. So let's consider all these. So L if is equal to zero, then it will only return true if the characters if the char on both string is the same. So if and the j is less than n and both are the same, yes, I equal to s2 j, right? And that's the only possibility. It can be true, otherwise it will always be false. So we can just return on like increment on both. If the same, then we just I plus 1 and j plus 1. So we're gonna just move ahead one position on both strings and then check the next, check again. So and the L if if is smaller than 0. So what are we gonna do? So if it's smaller than 0, then we're gonna always move ahead on the first string. So if I is smaller than the n, otherwise if I is smaller than n, then we're gonna check. If I is larger than or equal to n, then it will always return false. Then we're gonna return I plus 1, j, and the diff will be less. We're gonna diff will be like increment by 1. All right. Oh, sorry. So for diff is smaller than 0, actually, which means because we do minus when we are moving on the first string, right? So we minus. So which means diff is smaller than 0. The first string is ahead of the second string, so we're gonna move on the second string actually. So it should be if and only if j is less than m. Sorry, my bad. Yeah, so it should be like this, and then we move ahead on j. And every time we move on j, we increment the diff, right? So and then if the difference is larger than 0, if diff is larger than 0, and then the I must be smaller than n so that we can move ahead on I on the first string. So we're gonna move ahead on the first string. And every time we move ahead on the first string, we decrease the difference by 1. All right. So these are all the conditions where there is a possibility that it can return true, right? Yeah, I think I can just update like this, return this. Oh, sorry. Move it here, so we can just return this. And oh, sorry, it's not written because we still need to do a check, because here we need to check all the possibilities. So even if the current one is false, like if current one is false, then we can still increment k. Like even if like for example, use the example 2 here, even if like do 1 and it's returning false, we can still check 1 and 2, check 12, right? So this is check all the possibilities of all the values we can form by the digits. Yeah, so sorry, this is not, this for here we have to do if. Yeah. All right, and I think it should work. Let me double check the logic to make sure it's correct, and then let's run. Yeah, it does. So okay, so yeah, so basically this is the algorithm, and yeah, and I'll see you guys in the next question.